The formation of the Earth. The formation of the Earth is a complex and fascinating process that scientists have been studying for centuries. While there are still many unanswered questions and ongoing research, there is a general understanding of the Earth's formation that has been developed through various scientific disciplines. The early solar system. The formation of the Earth can be traced back to the formation of the solar system itself. The solar system formed around 4.6 billion years ago from a cloud of gas and dust that was left over from the explosion of a previous star, known as a supernova. This cloud, known as a nebula, began to collapse under its own gravity, causing it to spin faster and flatten into a disc-like shape. The center of this disk, where most of the matter was concentrated, became the Sun. The rest of the material in the disk began to coalesce into smaller bodies, called planetesimals, which eventually formed the planets and other bodies in the solar system. Planetesimal accretion. The formation of the Earth began with the accretion of planetesimals. These small bodies collided and stuck together, gradually growing in size and mass. The early Earth was bombarded by these planetesimals, some of which were several kilometers in diameter. The impacts from these collisions were so intense that they caused the Earth to melt completely, forming a magma ocean. Over time, the Earth's surface began to cool and solidify, forming a crust. The lighter elements, such as silicon and oxygen, rose to the surface, while the heavier elements, such as iron and nickel, sank towards the center of the Earth, forming the core. Formation of the atmosphere and oceans. The Earth's early atmosphere was composed primarily of hydrogen and helium, which were the most abundant gases in the solar nebula. However, as the Earth began to cool and solidify, these gases were lost to space. Other gases, such as water vapor, carbon dioxide, and nitrogen, were released from the interior of the Earth through volcanic activity and gradually formed the Earth's atmosphere. The early Earth was also bombarded by comets and asteroids, which contained water and other volatile compounds. As these objects collided with the Earth, they delivered large amounts of water to the surface, which eventually formed the oceans. Plate tectonics and continental drift. Plate tectonics is the theory that the Earth's lithosphere, or outermost layer, is composed of several large plates that move and interact with each other. The movement of these plates can cause earthquakes, volcanic eruptions, and the formation of mountains. The process of plate tectonics began early in the Earth's history, as the cooling and solidification of the crust caused it to crack and form large plates. These plates moved and collided with each other, forming supercontinents and causing the formation of mountains and other geological features. The first supercontinent, known as Rodinia, formed around 1.1 billion years ago and began to break apart around 750 million years ago. The fragments of this supercontinent eventually reassembled to form the next supercontinent, known as Pangaea, around 300 million years ago. Pangaea began to break apart around 200 million years ago, eventually forming the continents we know today. The evolution of life. The evolution of life on Earth is intimately tied to the planet's formation and geological history. The earliest evidence of life on Earth comes from fossils that date back to around 3.5 billion years ago. These fossils show evidence of simple, single-celled organisms that lived in the oceans. Over time, life on Earth evolved and diversified, leading to the development of more complex organisms, including plants and animals. The evolution of life was influenced by a variety of factors, including changes in the Earth's climate. Subscribe.